Hello, this is Team RuneScape. My name is Maverick Collins. We have James Owen and Ron McKellen with our final milestone of Software Engineering 2 with Professor Hughes here at Grand Canyon University. And in this video, we are going to go over our final implementation of our ESP32 weather station that uses three IoT devices, DHT11 to capture humidity and temperature data, the PIR motion sensor to detect when someone's in proximity to our system, and a photoresistor sensor to capture real-time light data. Our code structure is a module C design. We have been using Git to have code implementation and pushes and pulls. And our initial project scope is completed with this final implementation of our three sensors, the PIR sensor, the HT11 sensor, and the resistor. Hiring summary, we added the DHT11 in class with the first milestone or two. And from there, we increased the complexity of our design in this final milestone, adding the photoresistor sensor to, I believe it's D5 or D18, and the, right here, D15, and the other one to D5. And now James will be going over the topics designs, and we'll follow it up with Ron giving us a live demo of our application.
Thank you, Maverick. Using the Mosquito protocol with our ESP32, we decided to add two new topics to incorporate with our two sensors, motion and brightness. Motion provides a binary value indicating whether movement has been detected. This payload allows subscribers to monitor real-time motion events within the environment. The brightness sensor provides a threshold-based output indicating bright or dark conditions. This payload allows users to monitor changes in lighting conditions as part of the telemetry system. Along with our other topics like temperature, humidity, and telemetry, all these all these sensor values have a new function that our friend Ron will that I will send over to Ron to explain in more detail.
So in our implementation, we now have two new topics for the motion detection and the brightness level detection. As you can see in the terminal, data is streamed in on the motion topic and the brightness topics respectively. And the brightness is just a simple binary value of 1 or 0 depending on whether the light threshold is met. Covering the photoresistor as shown in the video will cause brightness to go off, and letting it be uncovered again will then cause the brightness signal to be raised to 1. And looking at the actual dashboard, besides the previous humidity and temperature monitoring, you can see that the brightness monitor shows a graph of 1 to 0 over a given duration of time to show whether that is brightness threshold was met or not. The motion alerts also function similarly, and if there is the right amount of motion detected in front of the sensor, then it will go to 1, otherwise it will stay at 0. All of the things are arranged in a dashboard in a simple 4-panel layout, 2 on the top and 2 on the bottom, for a quick overview of the information, with a time series graph used for the alerts and brightness monitoring, so that way users can monitor the changes over time. Now after you, Mav.
All right, that concludes our presentation for milestone 5 and of our ESP32 weather station. Thank you guys all for your time and for following us on our journey, and we'll see you guys in the next one.
And as one last thing, definitely, there were definitely a bit of trouble with the wiring sometimes, so getting used to that was definitely a big challenge, as well as just the general issue of debugging the network in the beginning. But really, I think debugging skills were the most important thing to be learned from this project. Thank you, everyone.